In this video, we're going to talk about twisted pair copper cabling in detail, and so let's go ahead and let's get into it. So what is twisted pair networking cabling? Well, it is a cable that is coated with 4 different pairs of twisted cabling in it. And you'll notice that we have 1, 2, 3, and 4 different pairs. And what you'll notice is that they are color coded differently, and one of them has stripes and one doesn't have stripes. So why is that? Well, with each pair, there's going to be a positive and negative electronic signal, and so they balance each other out and they complete a circuit. And so that's why there's a positive and negative for each one. Now, a bigger question is, why are they twisted together? Because you could easily just create this network cabling and bundle it together and not twist them. But there is a specific reason why they are twisted together, and that's to help reduce interference. And we're talking about electromagnetic interference and crosstalk. So there are 2 types of interference, is electromagnetic interference, and the second one is crosstalk. So let's start with electromagnetic interference. What is that? Well, that's when electronic signals emanate outside of the coating here that's covering this copper cabling, and it can potentially interfere with the other cables. Not only with the cables within this one single strand, but potentially other cables that are near it. So maybe there is another type of cabling next to it, such as a phone cable, or maybe just an electrical line. And electromagnetic interference can cause issues with our data lines because it can cause signal degradation, and it can cause us to have corrupted data if there is too much EMI. Now, the second one with these twists is that they help prevent crosstalk, and crosstalk is a type of EMI where the EMI is going from one cable to the next. And here's a good example down here. So for example, we have a signal here on our orange strand, and it's jumping down to all the other cables, and it's causing signal degradation. So that's why we have it. Now, there's a security concern with this type of cabling, and that has to do with the EMI. And so when you have this type of cable, it can emanate electronic signals outside of this cabling, and that's what causes EMI. Well, when that happens, when you have hackers, if they're good enough, they can actually pick up on that EMI and those signal emanations and try to pull data off of it. So there are security concerns when you use this type of cabling in a networking environment. Now, in regards to this type of cabling in general, it does have a maximum distance before you have to hook it up to some sort of repeater, whether that's a router or a switch or a hub, and that is 100 meters. So one strand of this cabling can only go for 100 meters before you have to go ahead and hook it up to a switch or router, where it repeats that signal and it strengthens up that signal. Because what happens over time, as it goes down this 100 meters, is that the signal gets weaker and weaker and weaker, and what they've determined is that 100 meters is the maximum distance that we can go before the signal gets too weak for it to be useful. So let's go ahead and jump to the next slide, and let's talk about 2 specific types of the cabling. And there's 2 specific types. One is shielded and one is unshielded. And the shielding that we're talking about is right here. You'll notice that there's this metal shielding here and there's none here. And again, there's a specific reason for this. And so we talked about our security concerns with our signal emanations in EMI. Well, when we have this shielding in place, it goes ahead and it reduces the signal emanations and it reduces the EMI. And so it protects against electric interference, not only from electric signals that are going out from here, it prevents them, but it also prevents ones from coming in. So it'll block other cables as well from interfering as well. And so it acts as a shield, like a metal shield, just like it is. Now, the other one is unshielded twisted pair, where there's no shielding, and this is the most common. So the reason why this is more common, because it's cheaper and it's more inexpensive, and that way it makes it much more affordable for wide use across multiple industries. Typically, you're going to see this in network cabling runs out from cubicle to cubicle, or where there's no other electrical cabling around it. Typically, where you're going to see shielded twisted pair is where you have cable runs close to other electrical equipment or electrical cables. So for example, if they're running cables from some sort of electrical closet up into the ceiling along the same lines as the other electrical lines, you're going to have shielded twisted pair, but by the time it gets out to the cubicles where there's not that many electrical signals around, then they're going to use unshielded twisted pair. So let's go ahead and let's talk about the different types, because there are different categories of these, and the categories determine how fast these type of cablings can be, meaning what type of bandwidth that they support. So there's category 5, category 5E, and category 6. And here's an image of them three. So we have Cat 5 here, we have Cat 5E here, and we have Cat 6 here. Now, I do have this image as a full screen on the next slide, but if we take a look, the cabling here is the exact same. However, the only difference is the number of twists per cable. And so the more twists you have, the faster speed it supports, the less signal emanation it has, the less EMI it has, the less crosstalk it has. And so the speeds that it supports are much higher. So for category 5, it's 3 to 4 twists per an inch of cable, which is right here. And that'll support up to 100 megabit per second Ethernet. And Ethernet is simply when we're talking about the networking. Category 5E has more twists than Cat 5, and what you'll notice here is that you can see more twists, and it supports 1 gigabit per second network speed. And then Cat 6 is the fastest out of these three. And again, this one has many more twists. So if we look at here from here, you're going to see a huge drastic difference in twists per an inch. And this will support up to 10 gigabit per second. So we're going from 100 megabit to 10 gigabit per second just from going from here to here. And the cabling itself is the same. The only difference is the number of twists per inch. So let's go ahead and let's jump to the next screen so you can see a bigger picture. And there you go. So if we look at here, you'll notice for each inch, from here to here, we only have a minimal amount of twists, but when we get up here, we have numerous twists. And so those twists allow higher bandwidth speeds because of all the benefits that it gets in regards to reducing EMI, reducing crosstalk, and reducing signal emanation. So that's going to go ahead and conclude this lecture. If you have any questions about twisted pair coupled cabling, please wait until the end of this section because we're going to talk about it a bit more after we talk about fiber optic cabling as well. But by the end of the question, if you still have questions about twisted pair cabling, please let me know as usual. And if not, thanks for watching, and we'll see you at the next video.